Chapter 15 of How It Flies, or Conquest of the Air. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information, or to volunteer, please visit LibriVox.org. How It Flies, or Conquest of the Air, by Richard Ferris. Chapter 15 Balloons, How to Operate. The actual operation of a balloon is always entrusted to an experienced pilot, or captain as he is often called, because he is in command, and his authority must be recognized instantly whenever an order is given. Nevertheless, it is often of great importance that every passenger shall understand the details of managing the balloon in case of need, and a well-informed passenger is greatly to be preferred to an ignorant one. It is ordinarily one of the duties of the captain to inspect the balloon thoroughly, to see that there are no holes in the gas bag, that the valve is in perfect working order, and particularly that the valve rope and the ripping cord are not tangled. He should also gather the instruments and equipment to be carried. The instruments are usually an aneroid barometer, and perhaps a mercury barometer, a barograph, recording barometer, a psychrometer, recording thermometer, a clock, a compass, and an outfit of maps of the country over which it is possible that the balloon may float. Telegraph blanks, railroad timetables, etc., may be found of great service. A camera with a supply of plates will be indispensable almost, and the camera should be provided with a yellow screen for photographing clouds or distant objects. The ballast should be inspected, to be sure that it is of dry sand, free from stones, or if water is used for ballast, it should have the proper admixture of glycerin to prevent freezing. It is essential that the inflating be properly done, and the captain should be competent to direct this process in detail if necessary. What is called the circular method is the simplest, and is entirely satisfactory unless the balloon is being filled with pure hydrogen for a very high ascent, in which case it will doubtless be in the hands of experts. When inflating with coal gas, the supply is usually taken from a large pipe adapted for the purpose. At a convenient distance from the gas main the ground is made smooth, and the ground cloths are spread out and pegged down to keep them in place. The folded balloon is laid out on the cloths with the neck opening toward the gas pipe. The balloon is then unfolded, and so disposed that the valve will be uppermost, and in the center of a circle embracing the upper half of the sphere of the balloon, the opening of the neck projecting a few inches beyond the rim of the circle. The hose from the gas main may then be connected with a socket in the neck. Having made sure that the ripping cord and the valve rope are free from each other, and properly connected with their active parts, and that the valve is fastened in place, the net is laid over the hole, and spread out symmetrically. A few bags of ballast are hooked into the net around the circumference of the balloon as it lies, and the assistants distributed around it. It should be the duty of one man to hold the neck of the balloon, and not to leave it for any purpose whatever. The gas may then be turned on, and, as the balloon fills, more bags of ballast are hung symmetrically around the net, and all are continually moved downward as the balloon rises. Constant watching is necessary during the inflation, so that the material of the balloon opens fully without creases, and the net preserves its correct position. When the inflation is finished, the hoop and car are to be hooked in place. The car should be fitted up and hung with an abundance of ballast. Disconnect the gas hose and tie the neck of the balloon in such fashion that it may be opened with a pull of the cord when the ascent begins. The ballast is then transferred to the hoop, or ring, and the balloon allowed to rise until this is clear of the ground. The car is then moved underneath, and the ballast moved down from the ring into it. The trail rope should be made fast to the car directly under the ripping panel, the object being to retard that side of the balloon in landing, so that the gas may escape freely when the panel is torn open, and not underneath the balloon, as would happen if the balloon came to earth with the ripping panel underneath. The balloon is now ready to start, and the captain and passengers take their places in the car. The neck of the balloon is opened, and a glance upward will determine if the valve rope hangs freely through it. The lower end of this should be tied to one of the car ropes. The cord to the ripping panel should be tied in a different place, and in such fashion that no mistake can be made between them. The assistants stand around the edge of the basket, holding it so that it shall not rise until the word is given. The captain then adjusts the load of ballast, throwing off sufficient to allow the balloon to pull upward lightly against the men who are holding it. A little more ballast is then thrown off, and the word given to let go. The trail rope should be in charge of someone who will see that it lifts freely from the ground. The balloon rises into the air to an altitude where a bulk of the higher and therefore lighter air equal to the bulk of the balloon has exactly the same weight. This is ordinarily about 2,000 feet. If the sun should be shining, the gas in the balloon will be expanded by the heat, and some of it will be forced out through the neck. This explains the importance of the open neck. In some of the early ascensions no such provision for the expansion of the gas was made, and the balloons burst with disastrous consequences. When some of the gas has been driven out by the heat, there is less weight of gas in the balloon, though it occupies the same space. It therefore has a tendency to rise still higher. On the other hand, if it passes into a cloud, or the sun is otherwise obscured, the volume of the gas will contract. It will become denser and the balloon will descend. To check the descent, the load carried by the balloon must be lightened, and this is accomplished by throwing out some ballast. Generally, a few handfuls is enough. There is always more or less leakage of gas through the envelope as well as from the neck, and this also lessens the lifting power. To restore the balance, more ballast must be thrown out, and in this way an approximate level is kept during the journey. When the ballast is nearly exhausted, it will be necessary to come down, for a comfortable landing cannot be made without the use of ballast. A good landing place having been selected, the valve is opened, and the balloon brought down within a few yards of the ground. The ripping cord is then pulled and ballast thrown out so that the basket will touch as lightly as possible. Some aeronauts use a small anchor or grapnel to assist in making a landing, but on a windy day, when the car is liable to do some bumping before coming to rest, the grapnel often makes matters much worse for the passengers by a series of holdings and slippings, and sometimes causes a destructive strain upon the balloon. In making an ascent with a balloon full of gas there is certain to be a waste of gas as it expands. This expansion is due not only to the heat of the sun, but also to the lighter pressure of the air in the upper altitudes. It is therefore the custom with some aeronauts to ascend with a partially filled balloon, allowing the expansion to completely fill it. This process is particularly advised if a very high altitude is sought. When it is desired to make a long voyage it is wise to make the start at twilight, and to so avoid the heat of the sun. The balloon will then float along on an almost unchanging level without expenditure of ballast. Rain, and even the moisture from clouds, will sometimes wet the balloon so that it will cause a much greater loss of ballast than would have been required to be thrown out to rise above the cloud or storm. Such details in the handling of a balloon during a voyage will demand the skilled judgment of the captain. The trail rope is a valuable adjunct when the balloon is traveling near the ground. The longer the part of the trail rope that is dragging on the ground, the less weight the balloon is carrying. And at night, when it is impossible to tell the direction in which one is traveling in any other way, the line of the trailing rope will show the direction from which the wind is blowing, and hence the drift of the balloon. The care of the balloon and its instruments upon landing falls upon the captain, for he is not likely to find assistants at hand competent to relieve him of any part of the necessary work. The car and the ring are first detached. The ropes are laid out free and clear, and the valve is unscrewed and taken off. The material of the balloon is folded smoothly, gore by gore. The ballast bags are emptied. After all is bundled up it should be packed in the car, the covering cloth bound on with ropes, and definite instructions affixed for transportation to the starting point. It is apparent that the whole of the gas is lost at the end of the journey. The cost of this is the largest expense of ballooning. For a small balloon of about 50,000 cubic feet, the coal gas for inflating will cost about $35 to $40. If hydrogen is used, it will cost probably 10 times as much. In important voyages it is customary to send up pilot balloons, to discover the direction of the wind currents at the different levels, so that the level which promises the best may be selected before the balloon leaves the ground. A study of the weather conditions throughout the surrounding country is a wise precaution, and no start should be made if a storm is imminent. The extent of control possible in ballooning being so limited, all risks should be scrupulously avoided both before and during the voyage, and nothing left to haphazard. End of chapter 15.